Hey guys, so today we'll be discussing an interesting topic, and I wanted to cover you with you guys because I did not find a lot of resources on the internet which actually explains what I'm going to sell it over here. And trust me, you will be flabbergasted. Trust me that. So let's take for a simple example. What happens when you type www.google.com? As simple as that. What eventually happens? So what happened over here is that whenever you type www.google.com, you know, your browser you will type it in a given link URL link, right? So what happened is that the very first thing which we need to understand, this www.google.com is a human friendly term. You know, only you can understand it, not any not any machine. For machine to understand it, machine can only understand the internet protocol addresses. Like it can only understand something like one. Oh, my bad. It can only understand 142.0.190.129.1, right? It can only understand in these format, not in the format of English letters, especially. So now since we have understood this part, let's understand what happens. So we are discussing the point we are just entered, right? Before the request start, before the request start, there is something called HSTS. Okay, we are going to discuss something called HSTS. And what is this HSTS? Think of it like a preload list. You know, it contains a preload list of all the websites. It contains a preload list of all the websites which strictly support HTTPS protocol. Okay. For now example, I'm taking google.com, but it might be Facebook and something. And now you might be thinking that where does this HSTS sits? Okay, where does this sit? And why am I telling you now? Am I fooling you? No, wait. So this HSTS is something which is present with it's inbuilt in your browser itself, and majority of the browser actually supports it. So the reason is that to try to understand, no one today types HTTPS. They automatically start typing with the gold.com. You know, so your browser, what it does over here is that it will see that whether google.com follows this https or not. You know, so यहाँ पे दो तरह के list होंगे. There is a list which will strictly follow. You know, let's make it strict https preload list, and there will be another set which we'll talk about later. And if you want, you can explore it yourself. So just for the exploration purpose, you can just go over here, right? But this the link is hstspreload.org, right? So if you want, you can just go over here. So what eventually happens is that the very first thing which happens is that the browser will append the https. Okay, it wants to ensure that there is no mistake in the security. I know there is no protocol downgrade which is happening over the anywhere, right? So that's why we have this given thing. Now, as I had said over here, your browser has needs to have that IP address, right? It needs to have that IP address. So what happens is that your browser will have its own cache. Your browser will have its own cache. Let's maintain a cache over here. So your browser cache. So let's understand that if you had typed google.com like 1 minute ago, okay, let's say that if you had typed 1 minute ago google.com and again you type www.google.com, the information of this conversion like www.google.com का IP addresses ये तुम्हारे कैशे में स्टोर होगा, ठीक है, मान के चलो. तो if this information was stored in your cache, it would your browser could immediately fetch that logic this IP address and return back, so that it can start making the further connection protocols which we will discuss in this given lecture. So I hope from this point onwards it's pretty clear that why we need a browser cache itself. Why does the browser has its own cache? Because now if you had visited 10 minutes ago, then it makes sense कि browser cache में तो होगा ही. But let's make the picture more bigger. Now let's say that your browser cache does not have that information. Your browser does not have that information. What will happen now? So if your browser does not have it, think of it like an application, right? This is an application. So what might eventually happen is that it will talk to its OS. Your application will be running on your OS and it will talk to it. And OS will have its own cache. And similar to this, OS cache will check if google.com exists or not. Now you might ask me that, hey, why do we need this OS cache? Why do we even need this OS cache? But try to understand how many different ways you can hit the OS cache. This is not this is application. Let's say this Chrome, right? There might be another given application. Let's say Firefox, and this given Firefox, it would have been talking to the OS, right? Let's say that you first open Firefox, then you type google.com, है ना? Then you type google.com, then you hit the OS. OS somehow tried to resolve that for you, and then it stored in its cache, and then it returned back to Firefox. Now, what happened over here is that once this Firefox was closed, you say that okay, I do not want to use Firefox for some reason. You come back to Chrome, and you do the same operation again. Now, what will eventually happen is that your OS cache will be updated with the information. So that's why it's important to store this given information in your OS cache, right? It's important to store that. But let's understand one more thing. Do you think application is the only way where we can talk with the some like so try to understand. You can use something called ping. I hope so all of you would have done this thing in your school days. So you would have used ping google.com, right? And what would have happened is that this thing you would have run in a terminal, right? This thing you run in a terminal, and when you run in a terminal, what it eventually does is that it will talk to the OS and it says that hey dude, can you please help me out and figure out. So this is another way why OS cache is important. And let's say for a given example, even the OS cache does not have that. Let's say that OS cache does not have that. So now comes a bigger picture. Let's say that this is our whole computer. Okay, this is our whole computer. Now, what will happen over here is that since the computer does not have that information, who will the computer ask? The computer will ask the router. Okay, the computer will ask the router. Now, you might ask me that, hey, why do we need a router to solve this given thing? Try to understand, dude. You are not the only person who is connected to this given router. There might be your parents. Your parents would have also been okay. Do not judge my arrows right now. I'm just making a random arrows. But your parents would have been connected to this router as well. I know. And what would have happened over here is that ki even your let's say that your parents made a request for google.com. है ना? Your router somehow managed to figure out that google.com का IP address ये है and it returned back to your parents. Now after 2-3 minutes, your computer also made a request. So don't you think it would be appropriate to maintain a cache over here? Yep. So that's why we have a router cache as well. We have a router cache because now let's say your parents ping this thing. Now this information will be stored in the cache, and now if your computer checks with the router will say that hey dude, it will not tell your hey your parents actually look for google.com. It will say that hey dude, I have that information, and you know what I was going to say. Eventually, let's say for a okay, let it be. Let's not talk about here. So now, I'm just saying that there might be lot of different people would have explored some given different website, and your router would have cached that given information. And let's say that you have also started to visit the same website. So after this point, if the router load that given website quickly, you know what I was going to say, right? So let's not worry about that. But now let's worry that what happens if the router does not have it. If the router does not have it, it will talk to the internet service provider. Okay, let me maximize the screen. Your router will talk to the internet service provider, and the ISP, if it talks the internet service provider, think like this. Yeah, and again trying to understand. Your router is not the only person which is connected to this internet service provider. There might be a lot of different routers, and it might be your internet service provider would have been handling a lot of millions of users. So it makes sense over here that it to have its own cache, right? Again, I will not go down to the cache wala thing. Again, the ISP will check its own cache. If it does not have in its own cache, then our core logic begins. Then we have something called a full recursive lookup DNS resolver. Let me zoom in for you. So we will have, so if your ISP cache does not have the IP address, it will then start a process call. It will then full recursive lookup of the given. So what happens over here, I'll discuss, and I will further discuss why this is recursive. Because what happens is that from this point onward, your ISP will say that, hey, dude, I will do the extra work for you and I will explain you what is that extra work. So what happens is that when your ISP, the ISP will talk to the root name domain server. Okay, it will talk to the root name domain server. Guys, one more thing. I do not. I'm just picking all these things from my memory, so might be a little bit slow. But anyways, so your ISP will talk to the root name domain server, and the root name domain server, the way it works is that कि देखो वो क्या करता है ना कि सारी चीजों को एक अच्छे फॉर्म में कंटेन करके रखता है जैसे कि he knows the root name domain server knows that कि who handles the .com, who handles the .in, है ना, it who handles the .ai. So what it does is that कि the once it hits the root name domain server, it will say that, hey, I don't know that who handles google.com, but I know that ki, who handles .com. It will just say this information to you. That's why that's the only information which you will get. Okay. So again, I'll repeat for you. It I don't know, but I know who handles all .com domain. Okay. This so understand this fact. This is a root name domain server. Okay. This is server. Understand, this is a server. And it will say that I know a server, I know a guy who knows a guy. It's kind of that thing. So before moving ahead, the root name domain server will say that the TLD, I know a guy from the TLD who handles the .com. Okay, so TLD क्या होता है? The resolve it. The thing is that once the information is returned, it will return some server name. It will return some server like the .com server manages all domain ending in. So what it does is that once it comes back with this given information कि देखो A कौन handle कर रहा है, it will go back to the full DNS resolver. But one more thing I want to put over here is that one more thing which I wanted to put is that कि जो तुम्हारा root name domain server होता है ना, दुनिया में सिर्फ 13 लॉजिकल रूट सर्वर्स है. ठीक है, देयर आर ओनली 13 लॉजिकल रूट सर्वर्स ओवर द एंटायर वर्ल्ड. एंड इट डज नॉट मीन कि वो जब भी लॉजिकल कभी भी बात कर रहे हो ना, इट डज नॉट डायरेक्ट. जब भी लॉजिकल और फिजिकल की बात करते हो ना, देयर इज नो वन टू वन मैपिंग. So these 13 logical root servers are spread across the entire globe. Okay, and internally they are managed by 1,000 plus physical servers. They are managed by 1,000 plus physical servers. So whenever your ISP, whenever it runs the DNS resolver, whenever it runs that, what happens is that it will the which logical servers to pick up. It will use a technology called Anycast. Anycast is like, I'll write it down for you guys. So Anycast is like it will find the closest server, closest root name domain server for you guys, and then it will ping that given server. So that's why internet is like, ऐसे नहीं बना दिया इंटरनेट को, like बहुत engineering लगा उसके पीछे. So now it says that hey, I know a guy who knows a guy. So now go talk to the top top level domain. Okay, talk to the top level domain server. ठीक है, बट ट्राई टू अंडरस्टैंड दिस. देयर माइट बी डिफरेंट टॉप लेवल डोमेन सर्वर. एक .com का हो सकता है, ठीक है, एक .com एक सर्वर हो सकता है .com का हो, एक सर्वर हो सकता है .in का हो, .ai का हो. ये इन्फॉर्मेशन कौन स्टोर कर रहा है? ये अपना रूट नेम डोमेन सर्वर स्टोर कर रहा है. ठीक है, इसलिए यहां से जब रिटर्न होता है ना, यहाँ पे एक सर्वर का एड्रेस मिलता है. अब तुम पूछोगे कि यार देखो .in में क्या होता है ना, .in का भी सेम ही आता है, बट टॉप लेवल डोमेन सर्वर उसका आता है .in वाला. ठीक है, वो डिफरेंट सर्वर को करिस्पॉन्ड करता है. तो अब फुल रिकर्सिव को पता चल गया कि ठीक है, मेरे को टॉप लेवल डोमेन सर्वर का डॉट मिल गया. अब वो उसे पूछता है कि डूड, कैन यू प्लीज टेल मी, प्लीज आई हैव बीन ट्राइंग फॉर सो व्हाट, कैन यू प्लीज टेल मी हु हैंडल्स google.com. So the theory comes is like कि top level domain server also do not know. But it says कि देखो, मुझे नहीं पता रैंचो कहाँ पे है, बट मुझे पता है कि वो कौन से जगह पे है. So it comes back over here and it says that I do not know where is the IP address of this google.com, but I know who is the authoritative of all the google.com. So एक authoritative server मान लो, ठीक है, एक central manager होना चाहिए. एक central manager है, manager who handles all google.com. ठीक है, this is the what is this? This is called the authoritative स्पेलिंग यार, यार स्पेलिंग मत पूछा करो मुझसे। करेक्ट कर लेना यार आजकल सारे। So this is the authoritative name server, है ना? So what it does is that it returns you the authoritative name server of google.com. ठीक है, ये भी एक सर्वर ही है। और इसका इंफॉर्मेशन कहाँ से आ रहा है? ये google.com का है ना, अथॉरिटेटिव सर्वर नेम रिटर्न करेगा। थिंक लाइक दिस कि तुम्हें बिल्डिंग का एड्रेस पता चल गया फाइनली। तुम्हें पता चल गया कि रैंचो छुपा हुआ है किसी जम्मू कश्मीर में, लेह लद्दाख में था, पता नहीं कहीं तो था, बट एटलीस्ट तुम्हें उतना तो पता चल गया। ठीक है, अब तुम उधर जाके एड्रेस ढूंढोगे कि रैंचो कहाँ पे है। ठीक है, थ्री इडियट्स, आई होप यू गाइस हैव वॉच्ड थ्री इडियट्स। सो वंस यू हैव फाउंड द google.com authoritative name server, you're then again, फिर इंफॉर्मेशन ऐसे फ्लो होगा, फिर अगेन फिर अपने डीएनएस रिजॉल्वर पे आएगा, डीएनएस रिजॉल्वर को मिलेगा कि इंफॉर्मेशन, एंड देन अगेन इट विल गो बैक टू द सेंट्रल मैनेजर हु हैंडल्स ऑल google.com। ठीक है, इट विल गो ओवर हियर एंड इट विल नाउ से दैट प्लीज रिटर्न मी बैक द आईपी एड्रेस। सो what do you think will happen? Do you think another google.com भी बोलेगा कि I do not know? No, यहाँ पे आईपी एड्रेस मिल जाए। We will finally find the IP addresses. So once we have found the IP address, it will return back to your DNS resolver, and I'll tell you what happens then. देखो, जैसे IP एड्रेस मिला ना, पहले एक चीज मैं डिस्कस करूँ, इसका रिकर्सिव नाम पता क्यों पड़ा? क्योंकि नाउ you know it is for your safety, it is handling the talk to root name, it has handling the top level and authoritative name server, and after that it is taking a decision. So जैसे अभी पता चला recursive, why we are using the term recursive lookup? So this is the reason, right? It recursively looks up for that information. Now what happens is this point is that कि जैसे ही IP address मिल गया, जैसे ही information मिल गया, this let's say that 192 नहीं बोलूंगा भाई, 142.1.10, let's say that you got this information, right? And then it got updated in your first thing is that in your ISP cache, internet service provider cache, ठीक है? Now the thing is that कि let me use a different color, नहीं तो सब same color हो जाएगा। So the thing is that कि it now goes back to your router, ठीक है? राउटर को मिल जाएगा इन्फॉर्मेशन, राउटर अपने कैशे में अपडेट करेगा, फिर राउटर जैसे ही अपने कैशे में अपडेट करेगा, राउटर बोलेगा कि ले भाई तेरा कंप्यूटर वन को बोलेगा ले भाई तेरा google.com मिल गया मुझे, फिर वो ओएस को बोलेगा, ओएस अपने कैशे में अपडेट करेगा, फिर ब्राउजर अपने कैशे में अपडेट करेगा, एंड दैट्स हाउ थिंग्स वर्क्स। सो डू यू थिंक दिस इज ऑल गाइस? डू यू थिंक मुझे इतना एक्सप्लेन करना था? नो, आई वांट टू एक्सप्लेन यू वन मोर इंटरेस्टिंग थिंग। So let me tell you what is the interesting thing. Okay, so how do you think the talk between the internet service provider and the router happens? देखो, तुम्हारे you there will be public IP address, ठीक है? There will be public IP address which is assigned to you, ठीक है? Let's say that your internet service provider would have assigned a public IP address, and at this point it would have assigned a public IP address and say that ki, hey, I found the IP address, now go back, return to this IP address. But the journey from router to the, you say, your computer is not straightforward. It's not straightforward because I will tell you why. When the packet reaches the router, it needs to know that किसने request किया था, कि किसने मेरे से पूछा कि where is this google.com. So what happened is that there is some further, I will go further down. Let me make this, oh, I don't want to make board clear though, काफी अच्छा लग रहा है. So what happened over here is that we will have something called a NAT. We will use a technology of NAT. What is NAT? NAT is a network address translation table. So let's say that कि देखो, there might be multiple devices which would have made different requests, है ना? So let's say that कि जो www.google.com का request है ना, this was made by a local IP address. इसका भी कोई रहेगा ना, ठीक है? See, the router would have assigned some internal IP address to you guys, है ना? It does not like कि your computer does not have a local IP. There's always a local IP address which is assigned to your computer. So it knows that the which Jesse, whenever once it receives the packet, once your router receives the packet from your ISP, it knows that ki which device I need to return this in. How it knows? It uses a network address translation. But this thing does not end here. Now to send the packet, to your laptop, or see, you might be connected to your router using Ethernet, Wi-Fi. I do not care. So now the way the communication happen is that it the router uses, after network address translation, it finds that कि ये given IP address था. So what it does is that it essentially broadcasts on your home network. जितने भी devices connected है ना, जितने भी devices connected है, your parents devices, and it says that who has this internal IP address. ठीक है, ये IP address है ना, local IP address. It broadcasts to all given thing. It gives computer C1, C2, everything, and it says that कि 192.168.1.5 किसका है. And once your computer identifies it, with it says that hey, that's me, and the computer responds with the MAC address. The MAC address. So now what happens is that I will not deep dive into it why the computer responds back, because the video will become unnecessarily long. But what eventually happens is that the router takes the IP packet. देखो पहले तो एक IP packet मिला रहेगा उसको. There will be some IP packet over here, है ना? And this IP packet will be wrapped in the L2 layer 2 frame. This IP packet would be wrapped in a layer 2 frame, and after this, this layer 2 frame will be addressed to your local laptop, or maybe something, anyone MAC address. Okay, and then it is sent over the Wi-Fi, and your Wi-Fi yaar, Wi-Fi. Okay, so eventually that's how your router receives that given information, and then uh, it receives the information from ISP, and then it transmits it to the your computer, right? So do you think we should stop here after making this whole mess? Do you think we should stop here? No, I will not stop here. So let's try to understand few more things. So let's say that once the you got the IP address, your browser will do a TCP handshake. It will do a TCP. Let me use a better. The next thing is that it will use a TCP handshake. Okay. Why this handshake is important, I'll tell you. देखो अभी आईपी एड्रेस मिला है, अभी तक हमें google.com का आईपी एड्रेस मिला है, अभी तक google.com पे जो गेट रिक्वेस्ट जाता है ना, we have not come up to that. So I'll tell you why. Because there has to be some communication, there has to be some line of reliable communication which has to be established between your client and the Google server. Your client would say that your browser sends a sync packet. Now it will say that your client will send a sync packet to the IP address. It will send a sync packet to this IP address, and I will further break down how this IP address also works. So it will send a sync address to this IP address, and client to the server. The server responds back with SYN plus ACK. Now it will again your it basically means देखो ये बोलता है हेलो, सर्वर को बोलता है, तो ये बोलता है कि देखो भाई, हेलो बैक, आई एम रेडी टू मेक अ कनेक्शन. फिर क्लाइंट टू सर्वर क्या बोलता है, ठीक है, एक्नॉलेज, हेलो बैक, आई एम रेडी, एंड आफ्टर दैट इट सेज दैट कि एसी के सिग्नल, एसी के एक्नॉलेज करता है और कनेक्शन एस्टैब्लिश हो जाता है. ठीक है, एज सिंपल एज दैट. आई नो दिस इज बिट शेकी, बट आई होप इट्स नॉट वेरी फैंसी टर्म. सो जैसे ही कनेक्शन, पहले अभी तक हमने कनेक्शन open किया, we have only, so we have only established the connection. Just understand this, guy. We have only established the connection. We have not started the communication yet. The connection is open, but it's not private. ठीक है, अभी तक जो कनेक्शन तुमने हैंडशेक किया है वो हाई हेलो किया है, बट यहाँ पे भी there can be some network attack, some can snoof, something like that. I'm not going to discuss that. So the browser, first of all, the browser sends an ACK, but the browser will initiate additional TLC handshake. ठीक है, sending about the information. See देखो, तुम्हारे browser है ना, जो तुम्हारा browser है, it will support different encryption method. It will support different encryption method, and the way it works is that it has to tell google.com कि देखो, I support all these encryption. The encryption might be like, for simplicity, it can be some different encryption. I do not remember the name right now, but the server also needs to return back and agree on that method. So let's say this is your application, and this is your server. Your application says that कि hey, I support these encryption. ठीक है, once the connection has been established to the server, server agrees on that method, and it says that ki, ठीक है, we agree on this. I'm sending you an SSL certificate, and together they generate some secret encryption for this session, and at the end everything sent between. So ये चीज मैं नहीं जाऊंगा, but ये SSL certificate भेजता है to the application will verify using a certificate authority, say कि whether this SSL certificate is valid or not, and after that there is some secret encryption key which is exchange which gets generated, not exchanged, but which gets generated for the session, and that's how the encryption, and we ensure that the servers are fully encrypted. Okay, so once this given information has been reached, what happens is that the server processes this. Okay, now अभी क्या होगा ना, अभी तो सारा information तो हो गया, but अभी क्या है ना, we need to send a fetch request. Why? Okay, तुम पूछोगे कि why fetch request? देखो, तुम्हें चाहिए क्या, google.com का क्या चाहिए तुम्हें, उसका HTML DOM चाहिए basically. You need that all the static files for the given google.com, only then it would have made sense for you guys. Making sense? So your client at this point sends a get request, क्योंकि अभी तो connection पूरा secured है ना यार. It will send a get request. Okay, after sending that get request, to this given server, ठीक है, the server processes and send back the HTTP2 response. Okay, देखो, अभी ना HTTP, अभी हम जो कितने भी communication कर रहे थे initially, it might be that it depends, but there are different alternatives, but first for our safety we will start the get request is eventually sent back in the HTTP2 response header. ठीक है, so the server actually responds back with the, यार ऐसे ही रहा तो, so the server eventually responds back with the HTTP2 response, and this response will contain HTML code. देखो, ये response है ना, this will contain the HTML code. Now what happens is that this is crucial because एक और चीज है response की, but this HTTP code, HTML code से your client will start building up the DOM tree. ठीक है, once it builds a DOM tree, I'll write it down over here. Once it builds a DOM tree, it will then realize कि उसको CSS files भी चाहिए, उसको कुछ image भी चाहिए, and further things like that. Okay, all these things. So once it starts building the DOM tree, parallelly the client will start making that further GET request, and the modern browsers are pretty fast. They will start dispatching the response for the CSS. They will start responding for the image things and all that stuff. So that's how the things works, right? And this HTML code, we have already, but ये जो response है ना, so I wanted to discuss one more thing. With this response, it also sends कि देखो, now in future if you, it just broadcast, देखो हर एक server ना अपने एक advertisement करता है. What advertisement? कि it says that देखो, I am supporting HTTP2, but in future it appends something like this, ALT SVC header. इसमें क्या भेजता है ना कि in future if you want a faster path, you can, I support HTTP3 over quick, so you can eventually use that for future visit. तो इससे होता क्या है ना कि देखो, इतना हैंडशेक किया ना हम लोग ने, ऑल द TCP हैंडशेक व्हिच वी हैव परफॉर्म्ड, ये हम सारा बाईपास कर सकते हैं यूजिंग दिस HTTP3 over quick, because quick is something, think of it like a UDP kind of format, but I don't want to cover, okay, I don't want to give you false hope कि ठीक है मुझे quick पता है. I have not used quick, but I know that works on some UDP format, and it's pretty much faster and it avoids unnecessary handshakes. So for given information, just understand this given thing. So अगर future में कोई भी request जाता है, तो अगर तुम्हारा, if your browser support HTTP3 over quick, then you can easily use this quick request, and it becomes pretty much faster, right? So this is where things are. Now, I think so it makes sense over here. I've explained you all of the things, but I wanted to ask you one final question. Okay? जैसे कि ये जो google.com है, what do you think? ये जो गूगल ऑथोरिटेटिव नेम सर्वर, ये क्या है? एट द एंड ऑफ द डे ना, दिस इज सम लोड IP address, this is some virtual IP address. Okay, try to understand this. Why this is virtual IP address? Can you think, guys? Can you first think why this is a virtual IP address? So there is a very valid reason behind it. देखो, जब भी तुम आईपी एड्रेस भेज रहे हो, इट करिस्पॉन्ड्स टू अ लोड बैलेंसर में, बिकॉज ना गूगल की जो बिल्डिंग है ना, वो उसमें काफी डिफरेंट फिजिकल सर्वर्स प्रेजेंट हो सकते हैं. देयर कैन बी मेनी डिफरेंट फिजिकल सर्वर्स विच आर प्रेजेंट ओवर द बिल्डिंग. सो देयर माइट बी फिजिकल सर्वर्स की बात करो, ठीक है. फिजिकल सर्वर वन, दिस माइट बी टू. अरे यार, टू बन जा, बट एनीवेज, ये टू है, ये थ्री है, ये फोर है. So what eventually happen is that now once you ping this virtual IP address, it hits the matlab thing like a mailbox. It's a mailbox, and eventually that goes to the load balancer, and load balancer will then assign this to a given physical server. Okay, and जब तुम्हें virtual IP address भी मिल रहा है ना, you're getting it of a load balancer, and then that's how the communication actually happens. So yeah, that's all, guys. And one more thing, you might ask me that ki, hey, why do we even need this top level domain server? Now think, guys, think. ये तो एक authoritative name server है, ठीक है, ये authoritative name server है. But what might happen is that, देखो यार, मैंने गलत बना दिया, इधर बनाना चाहिए था, बट ठीक है. इसलिए बोलता हूँ, इतना थोड़ा खिचड़ पिचड़ हो गया था. बट एनीवेज गाइस, व्हाट आई वाज सेइंग कि ये चीज ना सेंट्रल मैनेजर के पास होगी. पहली पहली बात तो ये है, यहाँ पे होगा ये वाला. और जो तुम्हारा ये है ना गूगल अथॉरिटेटिव नेम सर्वर, the thing is that now why top level domain maintains in this format is because the addressing can change now. Matlab, if tomorrow, if Google says that ki, I want to change its load balancer, assign some another virtual IP addresses or something like that, then it needs to handle it internally. It should not expose it. Matlab, top level domain server is handling lot of .com one. मतलब हो सकता है कि गूगल, फेसबुक, गिटहब, एंड ईच सर्वर लाइक गूगल आज सोचता है कि नहीं, आज मैं आईपी एड्रेस 142 नहीं रिटर्न करूंगा, मैं कुछ और रिटर्न करूंगा. सो इट वुड हैव टू गो टेल द टॉप लेवल डोमेन सर्वर, एंड इट वुड बिकम समथिंग विच इज वेरी नॉन स्केलेबल. सो इट मेक्स मोर सेंस कि तुम एक सेंट्रल अथॉरिटी रखो जो google.com हैंडल करता हो, एंड वो google.com तुम्हें बताएगा कि एक लोड बैलेंसर का वर्चुअल आईपी एड्रेस बता देगा. एंड जब भी तुम्हें अपडेट करना है ना कुछ भी, तो तुम सिर्फ अपने वर्चुअल आईपी एड्रेस को अपडेट कर रहे हो, ठीक है, वर्चुअल आईपी एड्रेस को अपडेट कर रहे हो, एंड वो उस तुम्हारे सेंट्रल मैनेजर उसको अकाउंट पे लेके उसको अपना जो भी रिक्वेस्ट है उसको उधर डायरेक्ट कर देगा. सो आई होप यू अंडरस्टैंड दिस वीडियो. आई नो दिस वाज अ प्रीटी लॉन्ग वीडियो, बट yeah, it all makes sense. कितना complicated है internet, right? It's not very simple thing. So that's it, guys. I wanted to make a further video on TC, uh, the TCP handshake and the dome structure, but I don't think so. It should be part of this video. So I hope you enjoyed it. Give a like, thumbs up. See ya.